Welcome to TUSD's Hazard Communications Right to Know training, prepared by the TUSD Risk Management Office. After this training, you will understand and have awareness of chemical hazards, protective and control measures, OSHA hazard communication standards, proper training, how to read labels and the hazard rating systems, understand what safety data sheets are, how to dispense, dispose, and store chemicals. You can prevent injuries and deaths caused by exposures to chemicals if you learn about the chemicals before you use them. Some injuries are caused by sudden reactions that happen when the wrong chemicals are accidentally mixed together. Other injuries and deaths happen because some chemicals can catch fire or explode, burn your skin, make it hard to breathe, cause dizziness and nausea, or lead to the future development of diseases. The Hazard Communication, or HAZCOM standard, requires that chemical manufacturers and importers provide hazard information to employers and workers. They must classify chemical hazards, place labels on containers, and prepare safety data sheets for each chemical. The labels and SDSs are tools that you can use to understand the chemical hazards. The way that labels and SDSs are written and set up make it easier for everyone who uses the chemical to find and learn about its hazards. This training program will help you learn about the information that must be on the label and the SDSs, or safety data sheets. There are safe ways to find out if hazardous chemicals are around us or have been released just by looking and detecting. There are workplaces that have equipment that detect presences of hazardous chemicals. However, employees often need to rely on other equipment and testing tools, such as litmus paper, or their own senses to detect the presence or release of hazardous chemicals. You should be familiar with the information on a chemical's appearance, odor, and physical and chemical characteristics before you work with the chemical. You should be alert for any chemical odors that might develop, but you should not purposefully sniff or try to identify chemicals or detect a release. The same rule applies to trying to identify a chemical by touching it, to find out if it feels oily, for example. A hazardous communication program takes steps to ensure that all chemicals in the workplace are identified, but if you encounter an unknown chemical, you should consider it to be hazardous and get more information about it before anyone uses it. There are two general types of chemical hazards: physical hazards and health hazards. A chemical can have both physical and health hazards. Chemical manufacturers and importers refer to 16 predefined physical hazard classifications, 10 health hazard classifications, and 2 environmental hazard classifications when they classify the hazards of a chemical. Each of those classes can have up to 5 subcategories. OSHA has no authority to require the environmental classifications, but you may see information on acute or short-term and long-term aquatic hazards on labels and safety data sheets. Once all of the hazards of a chemical have been classified, the warning statements, phrases, and other label elements are then specified. Classification information is also used to create a safety data sheet. A chemical is a physical hazard if it can damage the workplace environment. This means chemicals that are classified as having one or more of the following hazardous effects: explosives, flammable gases, flammable aerosols, flammable liquids, flammable solids, oxidizing liquids, oxidizing solids, oxidizing gases, self-reactive substances, pyrophoric liquids, pyrophoric solids, self-heating substances, organic peroxides, corrosive to metals, gases under pressure, or substances which, in contact with water, emit flammable gases. In addition to the physical hazards described in these 16 hazard classes, OSHA has defined 2 other specific hazards that can damage the workplace environment. A pyrophoric gas is a chemical in a gaseous state that will ignite spontaneously in air at a temperature of 130 degrees Fahrenheit or 54.4 degrees Celsius or below. You should also be aware that some dust can be combustible in some situations. A spark or flame can cause a combustible dust fire or explosion if, for example, a buildup of the dust is disturbed so that the dust is suspended in the air in a confined area. Substances that can create combustible dust when they are processed could include grains, sugar, and other types of food and agricultural products, charcoal, soot, and similar materials, chemicals such as sulfur, metals such as magnesium or aluminum, or plastic and resins. A chemical is a health hazard if it can cause an illness or other health problem. This means a chemical that is classified as having one or more of the following hazardous effects: acute toxicity, which means it's poisonous, skin corrosion or irritation, or burns, redness, or swelling, serious eye damage or eye irritation, respiratory or skin sensitization or an allergic reaction, germ cell mutagenicity, harmful changes to the cells in the reproductive system, carcinogenicity, reproductive toxicity or problems with fertility or damage to the developing offspring, target organ systemic toxicity such as lung or liver damage from a single exposure, target organ systemic toxicity such as lung or liver damage from a repeated exposure, or aspiration hazard, which is directly inhaling a harmful solid or liquid chemical or indirectly inhaling liquid after vomiting. In addition to these hazard classes, a simple asphyxiant is a substance or mixture that takes oxygen out of the air and can lead to unconsciousness and death. Some of these health hazards can occur fast, right after exposure, such as skin irritation or coughing. These are called acute issues. Health hazards can also cause long-term effects that usually follow repeated and long-term exposure, such as permanent respiratory problems. These are called chronic issues. Sometimes a chemical is hazardous, but it does not fit any of the hazard classes from the HAZCOM standard, and it is not a simple asphyxiant, a pyrophoric gas, or a combustible dust. The HAZCOM standard allows the classification system used in the United Nations Globally Harmonized System of Classification and Labeling of Chemicals, otherwise known as the GHS. OSHA did not adopt all of the classifications that are in the GHS, but they still consider some chemicals in this category to be harmful, and that is why all chemicals should be treated as if they can be harmful and make sure the workplace has all the chemical information needed. Another reason a chemical could have hazards not otherwise classified is if the chemical has hazards but it falls below the cutoff and/or concentration limit of a hazard class described in the HAZCOM standard. Hazards can be reduced or eliminated through the use of engineering, administrative, and work practice controls. Engineering, administrative, and work practice controls can include such methods as enclosing an operation to eliminate exposures, installing ventilation equipment to reduce exposures, substituting less hazardous chemicals, implementing chemical handling procedures, or other methods. If the hazards cannot be completely controlled or eliminated through other measures, personal protective equipment, or PPE, must be used. The employer assesses the need for PPE by looking at work areas and identifying sources of chemical exposures. Appropriate PPE is selected based on the assessment of the hazards and an evaluation of how effective the PPE is at protecting from the hazards. You may be required to wear goggles, face shields, gloves, chemical-resistant boots, chemical-resistant coveralls or aprons, respirators, etc. The PPE must be designed to be resistant to the chemicals you are using. You will receive additional training on the PPE you are required to use. Remember, PPE is only effective if you wear it. PPE does have limitations. For example, protective gloves or clothing can rip or tear, or a respirator may malfunction. Do not continue to use damaged or malfunctioning PPE. Fires, explosions, chemical burns, asphyxiations, and other incidents can be the result when hazardous chemicals are involved in an emergency. We have mentioned that unknown chemicals are to be considered hazardous. In the case of a chemical spill or release, the chemicals involved might be unknown. In this situation, it is especially important to treat all chemicals as hazardous. Specially trained emergency responders need to manage situations where unknown chemicals are involved in a release. Your role in the response may be to leave the area and report the spill from a place of safety. Since the conditions involving any chemical spill or release are unique, the situation could still require an emergency response even if you know the identity of a spilled chemical. Follow TUSD policies for reporting chemical spills and releases. Always follow the appropriate emergency procedures if a chemical release could result in a fire, explosion, serious injury, or death. Evacuate to a safe area and promptly report the emergency. Knowing how to promptly report an emergency is very important. Equally important is how to follow the proper emergency procedures. It is a good practice to always be aware of how to follow a safe evacuation route from wherever you happen to be working. Before you work with any chemical, find out the appropriate first aid measures for contact or overexposure to the chemical. First aid information is available on every safety data sheet. A specific section on the SDS will be provided later in this training. If you are overexposed to any chemical, you should take it seriously and report the incident right away because it can prevent a serious injury or illness. For many chemicals, the first thing to do if there is direct contact with the eyes or skin is to rinse with plenty of water. That is why OSHA specifically requires emergency eye wash stations and showers to be ready for immediate use near operations involving the use of harmful, corrosive materials and chemicals that will harm eyes and the skin. Know the locations of the emergency showers and eye washes in your work area and learn how to use them. If your employer posts maps of the workplace, the locations might be indicated on the maps. As discussed before, the first step for direct contact is to flush the eyes or skin with plenty of water. If your clothes are contaminated, remove them so you can directly flush your skin. A common first aid treatment for a chemical splash into your eye is to use an emergency eye wash station immediately. Look directly into the stream of the water and hold your eyes open with your fingers. Flush your eyes for at least 15 minutes. Seek professional medical assistance after any incident requiring emergency flushing. Another common exposure is breathing chemical vapors, gases, aerosols, fumes, or dusts. The typical immediate first aid response for this type of harmful overexposure is to take the victim to an area with fresh, clean air and call for emergency medical assistance. If hazardous chemicals are swallowed, it is not always the best practice to induce vomiting. It may also not be a good practice to have the victim drink plenty of water. In this situation, call a poison control center or emergency medical responder and have information from the SDS readily available. In 2012, OSHA created the Hazard Communication Standard and mandates that employers provide a hazard communication program in order to provide workers with information on how to work safely with chemicals. It is everyone's right to know. The standard allows workers to evaluate chemical hazards by using safety data sheets and a written hazard communication program provided by the employer. The written hazard communication program helps keep these HazCom efforts organized. The program describes how the employer meets the requirements for labels and other forms of warning, safety data sheets, and employee information and training. The written program must also include a list of hazardous chemicals in the workplace, a description of the methods the employer will use to inform employees of the hazards of the non-routine tasks, for example, bus drivers helping disinfect schools, and a description of the hazards associated with chemicals contained in unlabeled pipes in the employee's work areas. OSHA mandates that training must include accurate information on workplace hazardous chemicals. The training must be completed prior to beginning assignment or when a new chemical is introduced. Training must include appropriate work practices, personal protective equipment that employer has implemented for hazardous chemical protection. Training must also explain the employer's methods and devices to monitor hazardous chemicals, how to indicate the presence of hazardous chemicals with appearance and odors, and how to complete non-routine tasks that require hazardous chemical products. This information is found on the Hazardous Communication Program. Once again, everyone has the right to know. The purpose of labels is to warn about potential dangers. Labels are not intended to be either the only or the most complete source of information regarding the hazards or identity of hazard chemicals in the workplace. They serve as an immediate warning and as a reminder of the more detailed information provided in other places, such as the safety data sheets. Safety data sheets must be immediately available to employees so you have the detailed information you need. All container labels must be in English, but information may also be presented in other languages for non-English speaking employees. Labels are required on containers of hazardous chemicals. Container means any bag, barrel, bottle, box, can, compressed gas cylinder, drum, reaction vessel, storage tank, or the like that contains a hazardous chemical. However, pipes or piping systems in engines, fuel tanks, or other operating systems in a vehicle are not considered to be containers. Even though OSHA has changed the label requirements for the HazCom standards in March 2012, you will see shipped containers with labels that may only have the following information on them: identity of the hazardous chemical, appropriate hazard warnings, and name and address of the chemical manufacturer, importer, or other responsible party. Chemical manufacturers or importers classify a chemical's hazards, and they use that information to prepare the labels that you see on shipped containers of hazardous chemicals. Labels for shipped containers must have these 6 required elements. Product identifier. This is the name or number used to identify the chemical. It will also be used to identify the chemical on the safety data sheet and the list of hazardous chemicals in the employer's written hazard communication program. Signal word. This helps you know how severe the hazard is. The word danger is used for the more severe hazards, and warning is used for less severe hazards. Hazard statement. This is a brief statement for a hazard class and category to describe the nature of the hazard. Pictogram. This is a symbol used to show you the chemical's hazard class. There are 8 pictograms used to meet the HAZCOM standards labeling requirements, and 1 additional pictogram, which is not required under the HAZCOM standard, is used to show environmental hazards. Precautionary statement. This recommends the steps you should take to safely use, handle, and store the chemical. And finally, name, address, and telephone number of the chemical manufacturer, importer, or other responsible party. The responsible party is someone who can provide more information on the chemical and what to do in case of an emergency. Any hazardous chemical products that come in through your doors or leaves your workplace will have this type of label. This slide shows a sample label up close so you can better see all of the required elements: product identifier, signal word, hazard statements, pictograms, precautionary statements, and the name, address, and telephone number of the chemical manufacturer, importer, or other responsible party. There is no guesswork on the standardized elements. That information is provided within the HAZCOM standards required classification system, and once the manufacturer knows the chemical hazard by class and category, those label elements fall into place. The person who transfers a chemical product from the original or primary container into another container is responsible for labeling the secondary container. The label must contain the same information as the primary container, must be legible, will be displayed on the secondary container, and there will be no more than 1 label per secondary container. The label's pictograms are possibly the most visible aspect of the labeling system. There are 9 pictograms used. Here we see 3 of 9, and the hazards that they represent. Flame over circle is used for oxidizers. Flame is used for flammables, self-reactives, pyrophorics, self-heating chemicals, chemicals that emit flammable gas, or organic peroxides. And the exploding bomb is used for explosives, self-reactives, or organic peroxides. These 3 pictograms represent chemicals that have toxic, corrosive, or compressed gas hazards. Skull and crossbones is used for acute toxicity, which can be fatal or severe. Corrosion is used for skin corrosion burns, eye damage, or if it's corrosive to metals. And the gas cylinder is used for gases under pressure. It is important to note that the corrosion pictogram is used for both health effects and for physical damage. These last pictograms are probably the ones you will see most often. Health hazard is used for carcinogenicity, respiratory sensitizer or an allergic reaction, reproductive toxicity, target organ toxicity, mutagenicity, aspiration toxicity, or directly inhaling a harmful solid or liquid chemical, or indirectly inhaling liquid after vomiting. The exclamation mark is used for an irritant to the skin or eye, skin sensitizer, an allergic reaction, acute toxicity, which can be harmful, narcotic effects, dizziness, drowsiness, headache, nausea, etc., or respiratory tract irritant. You'll note that both the health hazard and the exclamation point are used for health hazards. The level of hazard dictates which pictogram is used. The health hazard pictogram indicates more severe hazards than the exclamation point. You might also see labels using an environmental pictogram to show aquatic toxicity hazards. OSHA's HAZCOM standard doesn't require the use of the environmental pictogram. Signal words are used to alert the severity of the hazard. There are only 2 that are authorized to be used. They are danger and warning. Danger emphasizes the more severe hazards, and warning indicates the less severe hazards. OSHA does not require a pictogram on the labels for 2 of the OSHA-defined hazards discussed earlier. For a simple asphyxiant, the signal word warning is required, along with the hazard statement may displace oxygen and cause rapid suffocation. No pictogram is required for combustible dust. The signal word warning is used along with the hazard statement may form combustible dust concentrations in air. A pictogram is used on the labels for the 3rd OSHA-defined hazard. The label for a pyrophoric gas uses the flame pictogram, the signal word danger, and the hazard statement catches fire spontaneously if exposed to air. The labels help you learn and remember the hazards of the chemicals you work with routinely. However, when you are assigned to a job that is outside of your regular tasks, the chemicals may have hazards that you do not run into every day. It is especially important to pay close attention to container labels in this situation. The labels can help you be sure that you are using the correct chemical for the job and that you are using it correctly. OSHA does not consider pipes to be containers, so they are not required to have HAZCOM labels. However, you must be informed of the hazards of the chemicals contained in unlabeled pipes in your work area, but it is good practice to indicate the contents by marking the pipes. There are two OSHA-compliant hazard rating systems that allow for the immediate understanding of basic hazards. One is the National Fire Protection Association, or NFPA 704 standard, and the other one is the Hazardous Materials Identification Systems, or HMIS. OSHA does not endorse or prefer either one. The NFPA, which is sometimes called the Fire Diamond, was created in order to alert emergency responders as to what type of chemicals might be in a building, vehicle, or container. The NFPA contains a lot of compacted information, but it is easy to understand. The diamond is broken up into 4 smaller diamonds, each with a different color that represents a different type of hazard. White indicates the specific hazard. Except for the white diamond, there is a number from 0 to 4 within each diamond that corresponds to the level of danger a chemical possesses. The higher the number, the more danger it presents, 0 being the least and 4 being the most. The HMIS rating system was developed by the American Coating Association in order to help users of chemicals identify hazards. The HMIS is also color-coded by hazard and uses a number system to identify the severity of the hazard. Blue indicates chemical health hazard, red indicates chemical flammability, orange indicates physical hazard, or yellow indicates reactivity hazard. The white areas may be used for a letter code of symbol recommending personal protective equipment. The numbers range from 0 to 4 and correspond to the level of danger a chemical possesses. The higher the number, the more danger it presents, 0 being the least and 4 being the most. Labels provide an immediate hazard warning, but you can find detailed information about a chemical's hazards on its safety data sheet. A safety data sheet, or SDS, is a fact sheet for a hazardous chemical. There must be an SDS available for each hazardous chemical in the workplace. Chemical suppliers provide the SDSs, but the employer is responsible for making sure the SDSs being used are kept up to date. The SDSs must be in English, but the employer may have copies in other languages as well. SDSs must be immediately available to you while you are at your work area. Copies must be kept where you can use them during your work shift. When employees must travel between workplaces during the day, SDSs may be kept at a central location. Let your supervisor know right away if you can't find an SDS or if you think one is missing. There are many reasons why you would want to check the SDS. For example, you may want to verify label information, determine if you are using the recommended PPE, learn about the symptoms of any health effects related to exposure to the chemical, and review recommended first aid and emergency procedures. The SDS will indicate if there is no relevant information available within a section. OSHA does not enforce sections 12 through 15, so an SDS may not have the complete information in these sections. SDSs must contain the following sections in the order listed. Section 1. Identification includes the product identifier, manufacturer or distributor name, address, and phone number, emergency phone number, recommended use, and restrictions on use. Section 2. Hazards identification includes the hazard classification and the required label elements. Section 3. Composition or information on ingredients includes the chemical name, common name, and synonyms. Chemical Abstract Service, or CAS number, percentages of ingredients and mixtures, and trade secret claims. Section 4, First Aid Measures includes necessary measures for each route of exposure, important acute or delayed symptoms and effects, and any immediate or special treatment requirements. Section 5, Firefighting Measures lists suitable extinguishing techniques and equipment, hazardous combustion products, equipment, and special precautions for firefighters. Section 6, Accidental Release Measures lists personal precautions, protective equipment, emergency procedures, and proper methods and materials for containment and cleanup. Section 7, Handling and Storage lists precautions for safe handling and storage, including any incompatibilities. Section 8, Exposure Controls or Personal Protection lists OSHA's permissible exposure limits, or PELs, threshold limit values, or TLVs, or other recommended exposure limits, appropriate engineering controls, and personal protective equipment, or PPE. Section 9, Physical and chemical properties list the chemical's appearance, its odor and odor threshold, and physical properties such as pH, flash point, upper and lower flammability or exposure limits, also known as UFL and LFL or UEL and LEL, vapor pressure and density, auto-ignition temperature, decomposition temperature, viscosity, relative density, etc. Section 10, Stability and Reactivity, lists chemical stability, the possibility of hazardous reactions, conditions to avoid, incompatible materials, and hazardous decomposition products. Section 11, Toxicological information, includes routes of exposure, symptoms, immediate and chronic effects, available toxicity data, and whether the chemical is considered to be a carcinogen. Section 12, Ecological information, which is non-mandatory, would include aquatic and terrestrial ecotoxicity, bioaccumulative potential, and ecological persistence and degradability. Section 13, Disposal considerations, which is also non-mandatory, would include a description of waste residues and information on safe handling and disposal. Section 14, Transport information, also non-mandatory, would include the proper DOT, shipping name, UN number, hazard class, and packing group. Section 15, Regulatory information, also non-mandatory, would include any product-specific safety, health, and environmental regulations. And Section 16, Other information, includes the date of preparation or last revision of the SDS. Working with hazardous chemicals requires knowing how to handle them properly to avoid both exposure and chemical spills. First, be sure you know the chemical's hazards. The following general precautions will help you handle many chemicals. Check the container label and the SDS to be certain that you are using the correct chemical. Wear all required PPE. For example, wear safety goggles and chemical-resistant gloves. Make sure any required ventilation systems are operating or work in well-ventilated areas. Take out only enough of the chemical that you need to use for the job. Keep containers closed. And do not use hazardous chemicals near sources of heat, sparks, and open flames. Mixing chemicals can sometimes cause dangerous reactions. Do not mix chemicals unless you have been instructed to do so. Do not reuse chemical containers unless you are certain of the previous contents and you are certain that there are no contaminants in the container itself. If you transfer chemicals to another container, wear proper PPE. Make sure the area has good ventilation, and be certain that you use the right type of container for the chemical. For example, safety cans are used for flammable liquids, metal cans are not compatible with strong acids, and some solvents can soften some plastics. In general, avoid using glass containers because they can easily break if they are dropped. Take extra precautions if you are transferring flammable liquids. Be sure to electrically ground and bond the containers. These liquids can cause static electricity to build up as they are poured or transferred, and a spark could ignite the flammable vapors. Grounding and bonding the containers drains the static electricity. Use only non-sparking tools to open drums containing flammable liquids, and use a pump to transfer flammable liquids from vertical drums. Use only a self-closing valve to pour flammable liquids from a horizontal drum. Hazardous chemicals must be stored properly to prevent spills, chemical reactions, and fires. Information on proper storage procedures is found on the chemical safety data sheet. You may have to keep the chemicals in a separate storage room or cabinet. There are detailed OSHA requirements for storing flammable liquids and for segregating and securing cylinders of compressed gases. Chemicals are still hazardous when you are finished using them. Many chemicals are regulated as hazardous waste. There are specific requirements for collecting and disposing of hazardous waste. Always follow all instructions for disposing of waste chemicals. It is especially important to be certain you dispose of the waste in the appropriate container so that no chemicals are mixed improperly. Never dispose of chemicals by pouring them into a sewer drain. Materials that have been contaminated with hazardous chemicals may also need to be collected and disposed of properly because they remain hazardous. In addition, follow all instruction for cleaning tools and other materials that have been used to handle hazardous chemicals. This training should have given you a good understanding of OSHA's HazCom requirements. It covered the following topics: the methods and observations that may be used to detect the presence or release of a hazardous chemical in the work area, such as monitoring conducted by the employer continuous monitoring devices, visual appearance or odor of hazardous chemicals when being released, etc. Information on the physical health, simple asphyxiation, combustible dust, and pyrophoric gas hazards, as well as hazards not otherwise classified. The measures employees can take to protect themselves from these hazards, such as appropriate work practices, emergency procedures, and the use of personal protective equipment, and the details of the hazard communication program, including explanations of the labels received on shipping containers, any workplace labeling system used on in-house containers, and the safety data sheet, including the order of information. If you have any questions on how you can obtain and use the appropriate hazard information for any chemical you are exposed to, always ask your supervisor for help before you use the chemical. Congratulations! You have completed the video portion of this training module. Now, head to topic number 2 and pass the quiz with an 80% or higher to receive credit for taking this course.